I think you'll agree that one of the biggest problems in learning science is that science is a completely different language. If you go into medicine, there's a whole different English language you need to learn. If you enter the world of astronomy, it's the same thing. That can obviously be intimidating. Some of the terms in science are named after a person who discovered them, so you're basically stuck memorizing last names like Hubble's law. Some terms are very specific to what they're referring to, like gastritis, where gastro means stomach and itis means inflammation of something, in this case the stomach. However, there are other terms that seem to just come out of left field, like quasars. What these are and how they came to be named as such will be explained in due course. Back in the middle of the 20th century, several people observed a source of radio waves called Cygnus A coming from outside of our galaxy. The spectrum of this radio source included bright emission lines, and it was redshifted as well. To explain what that difficult sounding sentence means, let me digress for a second. Quickly put, the spectrum is like a barcode for a product, but one pertaining to a specific celestial object, and the emission lines are like colorful barcode lines set against a dark background. This discovery of bright emission lines was actually unexpected. That's because a normal galaxy will have absorption lines in its spectrum, which are dark lines against a colorful background. To remember this, just think about absorption lines as absorbing light and thus becoming black, while emission lines emit light and become bright and colorful. The redshift I mentioned before indicates to us that this source of light is also very far away from us. That's important because despite it being very far away, even amateur astronomers using basic equipment can pick up its radio waves. All of these factors indicate that Cygnus A has to be a very luminous radio source as a result. Otherwise, we wouldn't detect it as clearly at such vast distances away from Earth. Another radio source, 3C273, was at first thought to be an odd, quote, star in our very own Milky Way galaxy. That's because it looked like a star in visual wavelength photographs. But over time, astronomers noticed that the recessional velocity, the rate at which an object moves away from Earth of 3C273, was way too fast for a star to remain in our galaxy for too long. This meant that such a radio source could not be an actual star, and instead had to lie outside of our galaxy. Since it was so far away and yet was detectable, it obviously had to be a powerful source of radio emissions and visible light. Therefore, such celestial objects were named quasi-stellar radio sources, shortened to quasars. Now you know where this odd term came from. With time, even more distant and similar star-like objects were found that actually had very little to no radio emissions, meaning they were radio silent. At first, such objects were called quasi-stellar objects, or QSOs, but nowadays the term quasar many times refers to both types, the radio emitters and radio quiet ones. Most quasars are radio silent. Now you should be wondering what in the world quasars actually are. Because I said before that the spectra of these guys are different from normal galaxies, they cannot be large and luminous galaxies. Instead, they are very luminous objects located in the centers of distant galaxies. Observing the galaxies these ultra-luminous objects are found in is difficult because their light overpowers the light of surrounding stars. How luminous are they? About 10 to 1,000 times more luminous than a large galaxy. But with better technology, astronomers did manage to find out some things. Nearby radio-quiet quasars are often located in spiral galaxies, whereas radio-emitting and distant quasars are likely to be found in elliptical galaxies. Furthermore, fluctuations in the brightness of quasars showed astronomers that they are small objects, smaller than our solar system, meaning quasars are small yet very powerful sources of energy, which are likely the active cores of very distant galaxies. Or, to put it another way, quasars are an extreme kind of active galactic nuclei, which are the centers of active galaxies that spew out huge amounts of excess energy. Such huge amounts of energy are believed to be released as matter swirls around and eventually falls into a supermassive black hole at the center of the quasar. During the first steps of their discovery, quasi-stellar radio sources were shortened to quasars, although now we know that not all of them are radio loud. Actually, some of them are radio silent. Although at first astronomers thought these objects were stars, they noticed that the recessional velocity, the rate at which an object moves away from Earth, was far too fast for one. Thus, with further research, astronomers realized quasars are small, yet very powerful sources of energy, which are likely the active cores of very distant galaxies, meaning quasars are an extreme kind of active galactic nuclei, which are the centers of active galaxies that spew out huge amounts of excess energy.